Welcome my dear students. Welcome to our Vidhyalakshmi YouTube channel. Now we are going to see about chemical kinetics. So this lesson in our plus 2 chemistry part, physical chemistry. In second lesson, physical chemistry, second lesson, chemical kinetics. Yes, in last year we studied thermodynamics lesson. In the same lesson, 7th lesson in 11th standard, same physical chemistry. The thermodynamics clearly tells about a reaction, a chemical reaction, how it's going to spontaneity or feasible of the reaction, chemical reaction. But in a thermodynamics, it does not explain the how far or the reaction speed, the rate of the reaction. So it does not explain the rate of the reaction. So that is a thermodynamics. But we need such chemical reactions, it takes some time, or such chemical reaction, it's getting quickly in manner. Such chemical reaction, it's very fast reactions. For example, best reaction, the curd, milk change into curd, it takes some time, for 4 hours or 5 hours. So this is the simple chemical reaction, it's kind of the biological reactions, but this reaction it takes some time. But the volatile liquids, especially petrol, if we take petrol and we pour to the ground, the petrol is evaporated into our atmospheric air. So that reaction is behind. So what we observe that kind of reactions. So that kind of reactions, it's a evaporation reactions. So that kind, or else it's called oxidation reactions. That oxidation reaction, it is over on in normal temperature. That reaction is a very quick reaction, instant chemical reaction, very quick reaction. The rate of the reaction we cannot predict because it's a very high or very fast reactions. So in such a way, we have many kind of chemical reactions in around our life. You see. Now chemical kinetics, what is meant by kinetics? Kinetics, the word coming from the origin Greek word, it's a kinesis. That means possibility to find out the speed. So that meaning. So chemical kinetics, we study about the chemical kinetics is nothing but to study the rate of the chemical reaction. Simply we say how fast is going on chemical reaction. See. Next. So objectives. We studied from this reaction, this lesson. So define what is meant by define chemical kinetics, classify the chemical reactions and describe the rate of the chemical reaction, calculate average and instantaneous rate of the reaction. So these are the factors, these are the topics we have discussed in this session. And you see, next, what is meant by chemical reaction? What is meant by chemical reaction? Chemical reaction is nothing but, it's a branch of physical chemistry which deals the study of the rate of chemical reaction. You see, the rate of chemical reaction. The rate of chemical reaction is the and the mechanism. So this is the chemical kinetics. The chemical kinetics in a simple chemical reaction, how fast is going to this reaction. Right, next, there are 3 important aspects of study chemical reaction. What are the 3 importance? So if we observe some chemical reaction in our life, in a day-to-day life, if we wear silver anklet in our anklet, so our ankles, so silver anklet, it sees, or silver ring, so it shows or it happens more than or 2 or 3 months, after 2 or 3 months, you look the silver ring, it's going to blackish in color. So what's the reaction behind that blackish color? So that means in a silver to react with hydrogen sulfide or sulfur in our air, so it changed into silver sulfide. That is silver sulfide, it's making the layer of the surface of that ring. So we can remove that silver sulfide. So this kind of reaction, it takes some time, sir, 2 weeks or 3 weeks or 2 months or 3 months. It's a very slow reaction or moderate type kind of reactions. So we study, so 3 aspects. What are the 3 aspects? Will chemical reactions be feasible? Yeah, it's feasible or not feasible. We studied in a thermodynamics part. If the reactions is feasible, how far it will be proceed and how fast a reaction would occur. How fast a reaction would occur. So this is the chemical kinetics. That mean by, so we find out the how far or how fast the reaction would occur in a simple chemical reaction. So we study this part in this lesson. Okay, right. Next, types of chemical reactions. So we have 3 types of, one very fast reaction, another one is very slow reaction, very fast reaction, very slow reaction, and moderate reaction. What are the 3 types of, chemical reaction? Very fast reaction. So what is meant by very fast reaction? That reacts almost, this kind of reaction which occurs almost instantaneously. The rate such reactions cannot be determined easily. In a fast reaction, we couldn't find the rate of the chemical reaction. We couldn't find. We determined easiest manner. But very slow reaction, you see the very slow reaction. In this type of comparisons the reactions which occur very slow rate. The rate of the such reactions hardly any physical importance. That means, so the very slow reactions only, it is unable to find out the rate of the chemical reaction. It's a very slowest process. Next one, the moderate reaction. Which one is the moderate reaction? You see, so this is the moderate reaction. This moderate reaction means in between the very slow and very fast reaction. You see, this is cellulose and starch. The cellulose and starch is nothing but it's our eatable things. If we ate some food, if we ate some food or hard food or light food, so finally the eatable things is going to converted into glucose in nature. So glucose, you see the glucose in nature. So this glucose, it is converted from its higher molecules of the cellulose and starch or like that. So these are the higher compounds converted into the glucose. It's a moderate speed in time. Because we ate morning breakfast and we take morning breakfast, after 2 or 3 hours, we have our body, it needs some food. We feel hunger in our nature. So that time we ate our body, it takes some food. Because if we take morning food, it's completely oxidized or it completely hydrolyzed or that means it digests. So that reaction, it's a moderate speed of reaction, moderate speed, rate of reaction. You see, next example, reaction speed, very fast reaction and very fast reaction. Example, magnesium and hydrochloric acid, sodium and water. If we take sodium and water, students, if we were into our chemistry lab and we take some sodium, we are not taking because sodium metal always kept in kerosene. Otherwise, we take it out and we put into the water bottle or we put into the water beaker. Within a second, instantaneous, it's catching fire. So burning matching sticks, combustion of fuel. So these kind of this kind of chemical reactions, very fast reactions, and moderate reaction, food spoiling, rusting of iron, baking of cake, food digestion, cooking, etc. Very slow reaction, you see, forming of diamonds, and forming of diamonds is coals, petrols, it takes some more than thousands years. It's a very slow reaction, and we couldn't find out the rate of the chemical reactions of very fast and very slow reaction, but we find out easily to find out the rate of the chemical reaction, especially moderate kind of chemical reactions, right? Next we see rate of the reaction. Sir, what is mean by rate of the reaction? In previous part we discussed about how many types of chemical reaction and what are the chemical reaction, how it's going to fast or slow or moderate. So these kind of variable chemical reactions we discussed. Now what is meant by rate of the chemical reaction? In a chemical reaction, the change in the concentration of the species, The change in the concentration of the species involved in a chemical reaction per unit gives the rate of the reaction. That means if we take if a chemical reaction, we need two kind of part. One left part is a reactant and right part is the product. So left part reactant, the reactant is the very important species of the chemical reaction. So the reactant side, the concentration of the reactant, it will be decreases and the product side will be increases. So this is the chemical reaction. That mean by the concentration of reactant suppressed and the concentration of the product increases. So this is the simple chemical reaction. Then what is the rate of the chemical reaction? You see, in a chemical reaction, the change in the concentration of the species involved in a chemical reaction per unit time gives the rate of the reaction. Simply we say, if we see in physics, in our physics, velocity, how we find out the velocity? Velocity means displacement by time. The rate of change in time of displacement is called velocity. The same way in chemical reaction, the change in the concentration with respect to the time. The change in the concentration with respect to time, so that is called rate of the chemical reaction. In a chemical reaction, you see the rate of the chemical reaction or speed or velocity, that means we correlate with that velocity in nature. So the chemical reaction, the rate of the chemical reaction, change in the concentration, you see in left part reactant side, students listen. So in left part, you see in a reactants, it's giving to products. So reactants, the concentration part, if we draw or if we put a square bracket, the square bracket indicate for concentration bracket. So if we take A is one of the chemical one of the reactant. So A is changed into B. So what is the rate of the reaction? A is changed into B. So A is the reactant. The concentration of the reactant, initially we are taking 100%. But time, we cannot start the chemical reaction. So that time is 0. Time is 0 seconds. We didn't find out the rate of the chemical reaction. If we take some time, that means T is equal to T times, or 10 minutes or 20 minutes or 15 minutes or 30 minutes. So that is the time. After taking some time, so the A is converted into or formed into product of B. In initial time, A is 100%, B is 0%. At T time, that means by T time, it forms some X percentage. We don't know how much it's formed. So, but X some percentage is formed. So that the chemical reaction. So we find out the rate of the chemical reaction, that means by change in the concentration of the reactant. So how much amount of concentration part, how much amount of the change in the concentration part of A concentration, how much it's reduced or how much it's converted into product side. So that is the rate of the reaction. You see, next. Yeah, see. So A is a simple chemical reaction. So yeah, so this is, you see, A is a simple chemical reaction. We change in time. So rate of the chemical reaction. So 2 times, initially T is equal to 0 at time, the A change into A1. When T is equal to T time, change into A2. That means A2 means it reduced some part of itself. So A2. So what is the difference between, and how much amount of decreased? So we measured like that, A1 minus A2. So A1, initially A1 is 100%. That means by English, you see. So A2 minus A1. So A2 minus A1 means A1 is greater than A2. Time T2, initial time T is equal to 0. That T, that is meant by T1 or T2. So 2 times we can take it. So T2 minus T1, thus that is meant by delta T, and A2 minus A1, that is called delta E. So the change in the concentration of the reactants divided by change in the time. So why we put a negative symbol? That is meant by a negative symbol. What is the meaning of that negative symbol? That negative symbol means the concentration part of the reactant side, it will be reduced or decreased. So that's the reason we put the negative part. And also if we calculate it, you see, initially we are taking 100 minus, after sometimes it taking 20% it's reduced. So remaining 80% is there, or 20% is reduced. So how much is mean? That by minus 80. So that minus 80 means that means it reduced. How much amount it will be reduced? Or 20% reacted. So balanced 80%. If I taking, you see. See, children, listen. So initial concentration 100, and after taking some times, so 100% initial concentration, 20% when t is equal to 0 means 100%, when t is equal to sometimes after 10 minutes, so it react with 20%. So remaining how much? 80% is there. So remaining part is there like that. So 20% of the reactants, it converted into product side, or it is changed into product side. So that mean by that negative part is indicate for decreasing the concentration part. So that is the meaning of that negative symbol. You see, if the reaction followed by measuring the product of the concentration rate given by delta B by delta T. So you see, so simple chemical reaction A to B. So the rate of the disappearance of A and the rate of the appearance of B. What is meant by disappearance? So disappearance means it's a reactance. So in a reactant disappeared and product appeared. So disappearance means we are taking negative symbol. So negative minus delta concentration of A divided by delta T, and appearance of the B, product. So it is mean by increase in concentration of B, time taken. So that is mean by plus delta B by delta T. What is mean by plus? So why we put plus symbol in this in a product side? That mean by product it will be increased or formed after initial time. Product it's a 0%, but it taking some times of 20 minutes or 30 minutes, the product it will be formed. So we put plus symbol for increase in the concentration of the product. So that's why. So B2, if we taking B1 is a product. B1 initially taking 0%. B2 it takes some percentage, 30% will be formed. 30% is formed. So that means B2 is greater than B1. B2 is greater than B1. So the constant rate of the reaction. So this is the very important question. The question will ask, write the rate of the chemical reaction. You see, write the rate of the chemical reaction of the simple process, simple reaction. You see, the simple reaction. So we write the minus dA by dt. dA for small change, deviation. That is meant by dA. In a change, it's taking some much amount or greater amount. It's we put delta A concentration part divided by delta T. So this is that, right? So if we are taking, so this kind of questions it will be asked. You see, next. So this is the simple schematic diagram of graphical method. You see, in a left part, that pink color parts. You see the pink color part. This pink color part. So this is called reactants. In the reactants, entirely change into green color. So this is the simple chemical reaction. In left side part is a completely reactants, and right side part is a completely products. So in between the stage is the reactants change into product side, and products it will be formed by reactant side. You see, we are taking the graph in between concentration term and time with respect to time. So concentration, you see, this is the reactant side. This is for reactants. reactants, and this is for products. You see, initially 1 mole or 1 concentration, molarity, molality, normality. So we are taking 1 molarity amount of some liquid or 1 molality part of one liquid. So it will be reduced by 0 itself with respect to change in time. At 0 time, at change into, you see, at 0 second or 0 time, 0 minute, the concentration of the reactant, it's completely 100% or 1 molarity or 1 molality like that. And time will increases. Time it will be increases. You see, time increases with respect to 20 minutes, 40 minutes, 20 minutes itself. And the concentration of the reactant, it will be decreases. So this is for negative slope. So the negative slope indicate the negative minus negative value. And the product, you see the product initially taking time, product it doesn't form 0 molarity, and the time will be increases, the product curve it change into, it's a positive slope. So it's getting positive in value. So this is the change in the concentration of product into reactants. You see, next, what is the unit of the rate of the reaction? Unit of the rate of the reaction. You see, the concentration of the substance expressed in mole liter. In mole liter, because we are taking concentration terms. Already we studied in 11th standard. 11th standard we studied concentration terms like molality, molarity, normality, and formality, like that. Yeah. Okay, students, listen. So the units of the rate of the chemical reaction. So the rate of the chemical reaction expressed in the term of mole liter. Mole liter with respect to time. So time we measured seconds or minutes or hour, whatever may be. Okay, right. So mole per liter. In a concentration term, mole per liter. So unit of the concentration is a mole per liter, and also unit of time is second or hour or minutes. So that's why we are taking right now. So the unit of the rate reaction, mole liter inverse or second inverse. We are taking second inverse. We are taking minutes, we are taking minute inverse. We are taking hour, it's a hour inverse. Right. Listen, right, in a gaseous reaction. So this is for only concentration of the substance. Substance means some quantity of the substance, 1 mole, 2 mole, and 1 molarity, like that. But in a gaseous reaction, simple reactions, you see A moles of A and B moles of the B, it gives C moles of the C and D moles of the D. This is the product. So these are all in gaseous phase. These are all in a gaseous phase. You see. So the gaseous phase. So in a gaseous phase, we never take that in a concentration part. So the concentration change into partial pressure, because so the partial pressure of this gaseous reaction. So in this time we are taking for in a ATM. So the concentration of the partial pressure we are taking in ATM. In last year we studied in chemical equilibrium lesson Kp and Kc. So Kc is a molar equilibrium constant. Kp is a molar partial pressure constant. If we are taking gaseous reactions, we are taking partial pressure, like that. So concentration of the reactants and the products are given in the terms of partial pressure. Yes. Okay. Listen, students. So the unit of the rate of the reaction is mole liter inverse second inverse. Right. Next, you see. So the rate expression. Sir, the rate expression for stoichiometric chemical reaction. In a chemical reaction, always in a stoichiometric in nature. Stoichiometry is a balanced chemical reaction. So that balanced chemical reaction, you see, the balanced chemical reaction means in left part of the. So balanced chemical reaction means, so A is the coefficient of reactants. A and B is the reactants and C and D is the products. So A is for A moles of A reactant and B moles of the B reactants. In this place, A and B, these are all coefficients of reactants. So, in a coefficients means we are taking stoichiometric in nature. So, right, in this part, in this time, we more observed in this kind of chemical reaction. You see, so the relative, I mean the individual rate of expressions, rate expression means what is it? Unit of the concentration of the chemical, I mean concentration of the rate divided by time. Concentration of the rate reactants divided by time. So the rate expressed in terms in various species of chemical reaction is called in a relative rate. What is meant by relative rate? Relative rates. What is meant by relative rates? Relative rates, it's mean by the equivalent by dividing the rate expressions. If you are taking so much of, you see, so this is that on a chemical reaction. A is the reactant and B is the product. Here 1 mole of A reactant is giving to 2 mole of the product. So 1 mole of the reactant is giving to 2 mole of product. That now 1 mole product is formed by half the mole reactant of A. So in this case, you see, for every mole of A that disappears, 2 moles of B appear. 2 moles of B appear. The rate of the formation of the B is twice the fast as the rate of the disappearance of the A. So you see, students, the rate of the reaction can be expressed. So the rate of the reaction, I mean product, rate of the product is dB by dt. So d for, it's a differential in concentration of B, that is meant by delta B, concentration of delta B divided by delta T, like that. So the change in time and change in the product, concentration of the product divided by change in time. You see, so the product 2 moles is formed, but 1 mole of product, 1 mole of 2 mole of product is that it's nothing that if, so we write that this chemical reaction, if write, we change into half the mole of A, it gives B. That this is the 1 mole product, half the mole of A, it's giving to 1 mole B product. So we write like that. So 1 mole of the product, it forms by the twice the values disappears of the A molecules, A reactants. So A means minus dA by dt by dt. So simply we say, so minus dA by dt is equal to 1 by 2 into dB by dt. 1 by 2 means it's the half the value. So 1 mole of A, it's giving to half the value of product B product. So that's the meaning of. So this is the stoichiometry. The stoichiometry means, so this is 1 mole and this is 2 mole. We are taking for equivalent values. So we are taking for equivalent values. That is mean by in a relative rates. Relative rates means, you see, relative rates in a moles minus 1 by A dA by dt and minus 1 by B dB by dt is equal to minus plus 1 by C in a dC by dt and plus 1 by D divided by D. So 1 by D and 1 by C, 1 by A, these are all indicate for, listen students, so these are all so the 1 by A value, 1 by B, so the 1 by C, these the value is coming from that coefficient values. But here it's a 1 mole, 1 mole, 1 mole, 1 mole are all equivalent moles. But in this kind of way, this is not equivalent. That means by 1 mole of A, it's giving to 2 moles of B. So the 2 moles of the B, it's 1 mole of B, half the mole. That means 1 mole of B, it's giving to half the mole of A. Or else 2 moles of the A, it's giving to 1 mole of the B. 2 moles of the A product, I mean 2 moles of the A, it's given to 1 mole of B, like that. So that is the, 2 mole of A, it's mean by, you see, half the mole of A, it's given to 1 mole of B. If we multiply both sides are 2, that means by twice the value of A concentration, it's giving to twice the value of B concentration. That means 2 into 1 by 2. So 1 mole of A, it's giving to 2 mole of B, like that. So that's why we are taking this 1 by minus 1 by 2 and minus plus 1 by 2 like that. Right. Next, you see the example for rate expression and the stoichiometry of the reaction. So let me see the one example. So simple example, H2 and I2 and 2HI. This is for one of gaseous reaction. So we are taking for the rate of that reaction minus dH2 because 1 mole. That's why we are taking 1 by 1 like that, 1 by 1 like that, minus dH2 by dt or minus di2 by dt or dH divided by dt plus that means by 1 by 2 here itself we write that. But 1 by 2 we never taking for 2 moles, we are taking for only 1 moles. So that is the relative number of moles. 2 moles we are not taking for 2 moles, we are taking only 1 mole. So we write the expression for the relative rate expression, it is getting to equivalent value of these values. And the reactants, you see the reactants and products have the stoichiometric coefficients. So it means 1 mole of H2 and I2 it disappears and 2 moles of hydrogen iodide it will be formed. The rate of the appearance of hydrogen iodide is twice the rate of the disappearance of the H2 and I2. Simply we say in stoichiometry means rate of the disappearance, rate of the disappearance equal to rate of the appearance. So this is the rate of the appearance, rate of the disappearance equal to rate of the appearance. So in this manner you see the stoichiometric in a chemical expression, rate of the expression. So the rate of the appearance is twice the rate of the disappearance of the H2 and I2. These two into, why we are putting 2 here? Because 1 mole is giving to twice the value its disappearance. So that's why we put 2 here itself. So 2 into minus dH2 by dt and plus dH. So twice the value of hydrogen iodates it's giving to 1 mole of hydrogen iodide formed. So simply we say half the mole. So we write change into half H2 plus half I2 it's giving to HI. So we are taking twice the value it's giving to the 1 mole. We are taking the twice the value iodine, that means by twice the value of in reactants it's giving to 1 mole of product like that. So you see similarly, so plus 1 by 2 and dHi by dt and dt. So this is for rate of the hydrogen disappearance, rate of the iodine disappearance and the rate of the hydrogen iodide forming appearance of the hydrogen iodide. So this is the so all the values are, you see, so these are the stoichiometric values. See next simply we say average rate of reaction and instantaneous rate of the reaction. Average rate. So in previous part we discussed about rate of the rate expressions and rate expressions and rate of the chemical reaction, how we find out the stoichiometric reactions. So these the factors, and next we are going to see about average and instantaneous rate of the reaction. Average rate of the reaction, what is meant by average rate and what is meant by instantaneous rate? Average rate it's defined as the rate of the reaction at particular interval time. So we are taking in a long duration of chemical reaction at the average rate of the reaction, that mean by in a particular time intervals, that means 1 to 10 minutes or 10 to 20 minutes, 10 to 30 to 40 minutes. So each interval times, a particular interval times is called average rate of reaction. Instantaneous rate of the reaction, that rate of the reaction at that particular instant is called instantaneous rate of reaction. See, so we have a one more example. So let us understand about the average rate and instantaneous rate. In both rates, we are considering the isomerization of cyclopropane. Isomerization, it's a cyclopropane, alicyclic compounds change into alkenes. So aliphatic compounds, alicyclic change into aliphatic. So this is the isomerization. You see, we have one table is here. So the time 0 seconds in minutes, time in minutes, we are taking in minutes. So answer we put minute inverse. So 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, 30 minutes. We have a concentration part, more liter inverse, concentration part of the reactants. And the rate of the reaction is equal to the delta, the rate of the reaction is equal to delta cyclopropane divided by delta T. So change in the concentration of the product, reactants divided by change in time. So the rate over the entire 30 minutes, means, you see, in 0 time, at initial time and at taking final time. Initial time we have the 2 mole values, and final time we have the 0.69 mole liter inverse. So that means the change in reactants means minus A2 minus A1. A2 minus, so this is for A2 and this is for, see, this is for A2 and this is for A1. So A2 minus A1 and divided by, this is for T1 and this is for T2. So T2 minus T1. So minus 0.69 divided minus 2 divided by 30 minus 0, 1.31 divided by 30. So we take it. So this is the rate of that reaction. 4.36 into 10 power minus 2 mole liter inverse, minute inverse, because we are taking minute the value, minute inverse. And the initial and latest stage over the short period time. So that mean by, in every reaction, that mean by, you see, in initially it change into drastic difference and it's going to reduced by small changes. But average part of, you see, decreases an average of 4.36 in 10 power minus 2 mole inverse per minute. Each minute it's decreased by 4.36 in 10 power minus 2 mole liter inverse. Like an initial stage. So that mean by initial stage means, you see, 2.0 and 1.4. So this is T1 and this is T2 after 10 minutes. So this is for 10 minutes interval time. 10 minutes, and this is also for 0.69 minus 0.98. So 20 to 30 minutes. So 20 to 30 minutes. So that is meant by 10 minutes. So we find out 10 minutes difference. So we find out, so rate of the initial reaction we getting 6.2. Initially it's going to drastic difference and finally it's going to reduce the, a disappearance rate of the disappearance, it will be increases. Right, you see. Next, yes. Next, you see. So, but the instantaneous rate of reaction. In above the calculation, you see, we come to know the decrease with the time, the reaction proceeds, the average rate cannot be used to predict the rate of the reaction at any instant. So average rate of the reaction, we find out, so the overall rate, we know about overall rate and we find the mean value of this overall rate, so that is the average reaction. But instantaneous rate of reaction is we are taking particular instantaneous time, so that is so we change the rate of the reaction, change into minus d by dt, that is mean by at particular instant, small in distance. So that is called minus d by dt. Right. Next, one more example for instantaneous rate of reaction. Cyclopropane mole, 2 mole, 1 mole, 0.14 mole. So the question is, let us calculate the instantaneous rate of the isomerization of cyclopropane at different concentration. From the graph shown, the results obtained tabled. In general instantaneous reaction, you see, so this is the question. So this is the one, the values of graph. So the instantaneous rate of reaction, you see, the values it change into, the rate, half the value. So decrease the value for half the value. So the half the value will be decreases by, so half the value decreases, different concentration of half the value decreased. You see, so we find out the value 6.92 and we calculated rate of the divided by time, particular time, 2 divided by rate, time, So rate of the reaction is equal to concentration of the reactants divided by time. If we have rate, we have, and concentration we have, we find out the time t, at time t. So t means, so the concentration of the rate divided by concentration of the reactants. So rate of the reaction 6.92 in divided by 2. So 2 value and divide by 2 value and divide by 2 value. So we find out, we can get the same value. So here 1, it's not 2. So we are having, see, divide by 1, divide by 0.1. Divide by 1 and divide by 0.1. So we are getting the same value of average mean velocity 3.46 into 10 power minus 2 minutes. So this is the time for average time. So average rate of the reaction at particular time. So the same value, half the value will be decreases with the respect to same interval of time. So this is the instantaneous rate of reaction and average rate of the reaction. So we find out average rate of the reaction, we find out the whole interval or particular interval. So we find out the rate of the reaction is called average rate of the reaction. Instantaneous rate of the reaction is called, it's very small time, we are taking for small time between. So that is the average rate of, instantaneous rate of reaction. Okay students, listen. So this is, now we discussed, we learn about for rate of the chemical reaction. How fast the chemical reaction. So we find out rate of the, what is meant by rate of the chemical reaction, and the rate of the chemical reaction expression, how we write the rate of the chemical reaction, and we write the stoichiometric expression of the rate of the chemical reaction, and we find out the instantaneous rate of the reaction and average rate of the reaction. Okay, thank you so much. Thank you students.